The James Webb Space Telescope has just captured something that could change our understanding of the universe forever. A galaxy so ancient, so distant, that it challenges everything we thought we knew about the origins of the cosmos. Imagine looking so far into space that you're actually looking back in time, witnessing the birth of the very first galaxies, formed just a few 100 million years after the Big Bang. Now picture finding something even older than what our theories predicted, something that shouldn't even exist. And yet, there it is. This discovery isn't just another deep space image. It's a glimpse into a time when the universe was still in its infancy, a chaotic realm of swirling gas and darkness where the first stars were just beginning to ignite. The galaxy Webb has found is so far away that its light has been traveling for over 13 billion years to reach us. This means that what we see is not what the galaxy looks like today, but what it looked like billions of years ago, when the universe was less than 3% of its current age. The mere existence of such a structure at that time raises an unsettling question. Have we been underestimating how fast the first galaxies formed? Or is there something even more mysterious at play? To unravel this cosmic puzzle, we need to go back in time, not just through space, but to the very beginning, to the moment everything began. The James Webb Space Telescope, the most powerful space observatory ever built, was designed to peer deeper into the cosmos than any telescope before it. Its massive golden mirror and ultra-sensitive infrared sensors allow it to detect the faintest glimmers of light from the earliest galaxies, stretching the limits of what we can see. But even the most optimistic astronomers weren't prepared for what Webb just uncovered. While scanning a seemingly empty patch of sky, Webb's instruments detected something astonishing: light from a galaxy so ancient that it formed just 300 million years after the Big Bang. To put that into perspective, if the universe's 13.8 billion year history were compressed into a single calendar year, this galaxy would have formed around January 2nd, right after the cosmic fireworks of the Big Bang settled. It shouldn't be there, at least not according to our current models of galaxy formation. The earliest galaxies were thought to be small, faint, and irregular, slowly growing over time. But this one, it's massive, far too mature for its age, glowing with a brightness that suggests it harbors an unexpectedly high number of stars. This alone was shocking enough. But what scientists found next was even more surprising. The light from this ancient galaxy wasn't just old. It was stretched and warped in a way that hinted at something even more profound. If this galaxy formed so quickly and grew so large in the early universe, it raises a troubling question. Could our entire timeline of cosmic evolution be wrong? And if so, what does that mean for everything we thought we knew about how galaxies, stars, and even life itself came to be? Understanding why this discovery is so astonishing requires a quick dive into the science of cosmic history. When the universe was born in the Big Bang, it was nothing more than an expanding sea of hot, dense plasma. No stars, no galaxies, just a chaotic soup of particles. As the universe cooled, hydrogen atoms formed, and after a few 100 million years, the first stars flickered into existence, marking the end of the cosmic dark ages. Over time, these early stars came together under gravity, forming the very first galaxies. Scientists have long believed this process took time, millions of years of gradual assembly, with small galaxies merging and growing into larger ones. But what Webb has found suggests something else entirely. This newly discovered galaxy, which has been named Sears 93316, is far too bright, too large, and too well formed for such an early stage of the universe. Its existence implies that galaxies may have formed much faster than we thought, perhaps in just a few tens of millions of years instead of hundreds. That might not sound like a huge difference, but in cosmic terms, it's like discovering a fully grown tree in a forest that was supposedly planted yesterday. It's as if something jump-started galaxy formation, forcing it to happen far earlier than our models predict. And then there's the light itself. Because the universe is expanding, the light from distant galaxies is stretched into longer wavelengths, a phenomenon called redshift. The farther away a galaxy is, the more its light shifts toward the red end of the spectrum. This particular galaxy has one of the highest redshifts ever recorded, meaning its light has been traveling for over 13 billion years before reaching us. But here's where things get even stranger. If this galaxy is as massive as it appears, then the early universe must have been churning out stars at an unimaginable rate, far faster than we thought possible. And that raises a critical question. What force could have accelerated the birth of these colossal structures? Could there be an unknown mechanism at play, one that defies everything we assumed about the early cosmos? Discoveries like this don't just rewrite the story of the universe. They could change the way we understand our own existence. If galaxies were forming faster and earlier than we thought, it suggests that the cosmos may have been far more chaotic in its early years. More stars mean more supernovae, massive explosions that release incredible amounts of energy, sending shockwaves rippling through space. But what if some of these waves reached our own galaxy at a crucial moment in Earth's history? Could ancient cosmic events have played a role in shaping the conditions that made life possible? There's already evidence that Earth has been influenced by cosmic forces in unexpected ways. Some scientists believe that supernova explosions in our galactic neighborhood may have triggered ice ages by bombarding our planet with high-energy radiation, stripping away parts of our atmosphere and altering climate patterns. If galaxies, like Sears 93316, existed earlier than we thought, it means the universe was filled with intense radiation and stellar explosions much sooner. Could this have affected the formation of our own solar system? Perhaps even seeded the heavy elements necessary for life. And then there's an even wilder possibility. What if cosmic radiation from these ancient galaxies somehow influenced the very fabric of life on Earth? Some researchers speculate that bursts of high-energy particles from deep space may have played a role in genetic mutations over millions of years, subtly shaping evolution itself. It's a mind-bending thought. The oldest galaxies in the universe, born billions of years before Earth even existed, might have left fingerprints on the DNA of every living thing. But if that's true, then what else have we yet to uncover? Could there be other ancient cosmic forces still at play, influencing life and the future of our planet in ways we can't yet understand? This discovery doesn't just challenge our understanding of the past, it forces us to rethink the future. If galaxies could form and evolve so quickly in the early universe, what else might be out there that we haven't found yet? Could there be even older galaxies, ones that push the very limits of the observable universe? If so, Webb's mission may only be scratching the surface of a much deeper cosmic mystery. And then there's the question of our own place in all of this. If the early universe was far more dynamic than we thought, it could mean that habitable planets and even the conditions for life might have emerged much earlier, possibly billions of years before our own solar system even existed. If intelligent civilizations had a head start of billions of years, where are they now? Could they have long since vanished, or are they still out there, waiting to be found? This discovery also fuels the next great questions of astronomy. What mechanisms allowed these galaxies to form so fast? Were there forces at play that we haven't yet discovered? New physics beyond our current understanding? And most importantly, if our models of cosmic evolution need to be rewritten, what else might we be wrong about? For every answer Webb provides, it seems to open 100 more doors, each leading to bigger, more mind-bending possibilities. But perhaps the most profound realization is this. The universe is far more complex, far more mysterious than we ever imagined. And with each new discovery, we are only just beginning to uncover the true nature of our cosmic origins. The James Webb Space Telescope has once again shattered our expectations, revealing a galaxy that shouldn't exist, one so ancient and massive that it forces us to rethink everything we thought we knew about the early universe. If galaxies formed this quickly, what other secrets are hidden in the depths of space waiting to be uncovered? Could there be even older structures, perhaps remnants of a time before the Big Bang itself? One thing is certain. Every discovery like this brings us closer to answering the biggest questions about our origins, our place in the cosmos, and the forces that have shaped life itself. But now, I want to hear from you. What do you think this means for our understanding of the universe? Could there be unknown forces at play, accelerating the birth of galaxies in ways we don't yet understand? Let's discuss in the comments below. If you found this discovery as fascinating as I did, don't forget to like, subscribe, and hit that notification bell so you never miss the next mind-blowing revelation from the cosmos. Until next time, keep looking up. The universe still has so many secrets left to reveal.